Hello everyone and welcome back. We're going to continue through chapter 12 today, and this time we're going to be going over the motion of a projectile. So, after today you'll be able to analyze the free flight motion of a projectile. We're probably going to be hitting applications and getting to kinematic equations today. Maybe not kinematic equations, we'll see. So first off, a good kicker can instinctively know exactly what angle they need to kick the ball and how hard to make a field goal. Now, for a given kick strength, what angle should the ball be kicked to get the maximum distance? Because obviously if they kick it straight up, well, that's no good. If they kick it straight forward, well, that's not going to work either. It's got to be able to go over the goalpost. So it's somewhere in between those two crazy cases. Or if you're like trying to throw a free throw. Well, how's your aim? Mine is pretty terrible. I was pretty okay in 4th grade, but it's all been downhill since then. So when you're trying to make a basket, you have to shoot the ball at a certain angle. So what parameters should the shooter consider in order for the basketball to pass through the basket? Well, there's a lot of things here, but mostly it's that initial velocity. And you need to know the direction and the magnitude of that. And everything else should fall into place. With some assumptions. So, let's look through how we would figure this out. Oh, one more. A firefighter. If you want to put out the fire, you actually have to make sure the water hits there. So, if you want to get as high on the wall as you can, you're going to instinctively be able to do that if you move the water up and down. But how can you tell exactly where the water is going to peak? So all these cases are cases of projectile motion. Projectile motion can be treated as two rectilinear motions. One in the horizontal direction, experiencing zero acceleration. We are assuming that there's negligible air resistance. And the other in the vertical direction, experiencing constant acceleration, which is only gravity. And once again, from all these questions, we'll be assuming zero air resistance, a frictionless vacuum. Now, if we look at this, we look at the two balls on the left, what you see is that they both fall at exactly the same rate. Even though one of them has a horizontal velocity, the other one a vertical velocity, their vertical acceleration is constant, it's the same. And their vertical position is also the same. You also see that at every single time step, these are taken at equal times, the horizontal velocity of the ball does not change. It's the same. It moves the same distance in the horizontal direction every single time. So the horizontal velocity is constant, and the vertical velocity is accelerating with gravity. Okay. So what are our kinematic equations for horizontal motion? Well, since the acceleration is zero, this means that the velocity is going to be constant. Whatever our initial velocity is in the x direction, it's going to be what our final velocity is in the x direction. And we can very easily figure out where its x position is by using this equation right here. We know what the initial velocity is. There is no acceleration, so that last term just falls off. And we hopefully know what its initial x position is. So it's just a function of velocity and time. Now, as I was saying earlier, if we're saying that acceleration is zero, we have to assume zero or at least negligible air friction. Okay, now vertical motion, not quite so easy. We will have gravity, and that means when we look at our kinematic equations, it doesn't simplify so nicely. In the previous one, these two equations are exactly the same because the acceleration is gone, and so our initial velocity is equal to our final velocity. In this case, we can't do that because we do have an acceleration. So we'll get 3 different equations, which we'll need to use to solve problems. Now it says for any given problem, only 2 of these 3 equations can be used. So why do you think this? Why do you think this is? Well, you might have figured it out from our previous example where this equation and this equation were the same. These equations aren't perfectly independent. These are more or less the same way of looking at each other, just from a different perspective. So you can't actually use both of them in the same problem. Okay. Honestly, you can use any of the two, but still, just pick two and use those for your problem. If you try to use three, it will most likely not give you anything new, any new information. If it does, you've most likely made an algebraic error. Okay, so from here, we're going to start using these equations and the previous equations right here to start solving some example problems for our projectile motion. So, look forward to showing you that. I'll be back in just a minute. Have a wonderful day.